don't know if that's right, but if you're doing the distance across, right, you got square root -1 minus 3 squared plus 4 minus a -2 squared, -4 squared. So that's your diameter. It's got to get cut in half. Before you can do that, you have to simplify it. So this is 2 and 26, 2 and 13, and that becomes 2 square root 13. Then you have to cut it in half. So it becomes just the square root of 13 for the radius. And then when you plug it in, you got to square it. So this is how most people make mistakes. Like, if I could actually go back and look at the data on how many people attempt that one and get it right, it's slim. Just because easy mistakes are made. So I would avoid that method. I would find the center, which is what this work is. Find the center and then use the center with either coordinate point that's there and plug it in as your x, y, h, k.
It could be either one.
Yep, okay. Either one. That's definitely the higher success rate is for that method, I would say. Any other questions from this page, from the first page? Yeah.
Can you do number 4?
Any, like all of it or just the graphing?
The graph.
Okay. So when you're graphing your piecewise function, remember there's two ways to do it. One is graph the whole thing, erase what you don't want. The other is plug in points from the individual sections. So with a line, I would say it's probably not so bad just to plot your points. This has a y-intercept at 3. So I'd go up 1, 2, 3. I'd have a y-intercept at 3, and then your slope is 1. So you're either going up 1 and to the right 1 or down 1 to the left 1. That's your line. But then looking at this, you only want it to be where it is less than or equal to -1. So if I go to where my x is -1, it's here. And then I would have my arrow pointing left, and I would erase all the rest of it. And then the second one is your parabola. Now that we've done more, like hopefully you know the transformation, that's a parabola that shifted down 1. If I go down 1, I go up 1 and to the right 1 in both directions, my parabola would look like this, right? But it's only for where it's greater than -1. So this would be an open dot, and then my arrow would point to the right like that. If you don't know where that parabola goes, you can always plot some points. Like I would plug in points, but I would plug in from the range that they give you. So for the first one, I would plug in -1, -2, because I wanted to go less than -1. And for the parabola, I would plug in -1, 0, 1, because I want it to go greater than -1. And then because it's or equal to, it would get the solid dot for the parabola. If it's not or equal to, which is the line, that one gets the open dot. Other questions on that first one, on the first page? Yep. Correct. Yep. So you can either use the graph for those, or you could use the equations. Yep. But it's only one answer is going to be right. Yep. All right. Second page. Questions on, now we went into 1, 1, and 1, 2. 31. All right, 31 says, write the slope forms of the equations of the lines through A parallel, B perpendicular. So first of all, from this line, the one that you're going to do parallel and perpendicular, all I want from that is the slope. It's in standard form. So my slope is -A over B, -5 over -4, which is 5/4. So then when I do the equation of a line that's parallel to it, my slope's going to be the same, 5/4. When I do the slope of a line that's perpendicular to it, my slope's going to be opposite reciprocal, so -4/5. And then I want to use the point that they gave me. So do you do point slope or you do slope intercept? Point slope. So I would do y minus the -2 becomes +2 equals 5/4 x minus 3. Distribute the 5/4. Add or subtract the 2, which is 8/4. And I get y equals 5/4 x minus 23/4. Then what you're not going to do is carry over the b and just change the slope for the second part, because that's wrong. You have to start again from the beginning. This time, same point, but this slope. So y minus a negative 2 equals negative 4/5 x minus 3. Then distribute y plus 2 equals, distribute here, negative 4/5 x plus 12/5. Subtract the 2, or the 10/5, and I get y equals negative 4/5 x plus 2/5. The next came, and this is the one that's your graphing utility one. Okay, you want to make sure you know how to do all this. This is where you will start, is with your graphing utility. Everybody's good on that? All right, then it's kind of a mess on the left, but those are your piecewise functions. Questions from 1, 2, that the left is the continuation of 1, 2, which was piecewise, and then the difference quotient on the bottom. And then 1, 3's on the right. Right, so this is a square root. We know the parent function is the square root. I know because it's a plus 3 underneath, it is left 3, and then the minus 4 means it's down 4. So if I was to graph this by hand, I'd go left 3, down 4, and then it points up and to the right like that. So when it asked for, domain and range? Yeah, domain is your x values. The furthest left it goes is negative 3, so my domain starts at negative 3. It'd be a solid dot because it's not an open dot. And then it points to positive infinity. And then your range is bottom to top. So the lowest point was negative 4. 1, 2, 3, 4 is how far I went, negative 4. So my range is negative 4 to positive infinity. And then when you're checking it algebraically, it means follow the rules of your domain and range. Or not range, but domain. So there's a number under the square root or variable under the square root. What's there has to be greater than or equal to 0. So x would have to be greater than or equal to negative 3, which matches your domain. You're welcome. All right, so it says f of x would equal 3x plus 5 if it's less than or equal to 0. So remember, there's two ways to approach this. One is graph the whole line. So I'd go up to 5, and my slope would be up 3 into the right one, or down 3 into the left one, and my line would look like this. But I only want it, I did something wrong, right? One of them is not or equal to. This one doesn't have the or equal to. I only want it where it's less than 0, which means I would start at 0, but it would be an open dot there. It's not going to have the middle filled in. So it'd be an open dot at 5, and it'd be pointing to the left. And then I would erase everything on the right. The other idea behind it would be to plug in points starting at 0 and going left end. So I could plug in 0, I could plug in negative 1, and then connect those. Then the one on the right says x is greater than or equal to 0, where the equation would be x minus 4. So I start at negative 4, and my slope is up 1 into the right one. I know I'm not going to go left, so I'm not even going to waste the time counting down and left, but you could. But because it's greater than 0, I'm going to leave the solid dot at 0, and I'm going to point it towards the right. Now your domain goes left to right here. So if I have this arrow that's going to keep going this way, my domain's going to keep getting smaller and smaller and smaller. And I have this arrow that's keep going to go this way. So my domain is all real numbers, negative infinity to positive infinity. If there was a gap, and you'll get this on the class cake practice, but if there's a gap in between, like if I didn't have something on the 0, if it didn't start until maybe here, now I'd have negative infinity to negative 1, and then 0 to positive infinity. There'd be a gap in my domain. But that didn't happen. It overlapped. The same is going to happen with your range. Your arrows are pointing down and up from bottom to top. All of your values are there. So it would also be all real numbers. If there was a gap in range, so let's say this equation was actually up here. Now my domain would go from negative infinity to 5 with a parentheses on the 5, and then from 8 to positive infinity with a bracket on the 8. So that's how it would change if they did not overlap, but they did, so both of them were all real numbers. Any other questions from 1, 4, or 1, 5. All right, then came 1, 4 and 1, 5. Questions on either of those? I don't know if that's a good sign or a bad sign. I don't know if that's a you're so confident you're ready to go or you didn't do it. Yeah. Mm-hmm. All right, 97 is your transformation. So 1 over x minus 6. My parent function is f of x equals 1 over x. And then it's not inside the function, it's after it. So that's a shift down 6 places. So when I take my asymptotes, because that's how we shift the reciprocals, it's normally at 0. So normally it's here. Instead, I'm going to shift it down 1, 2, 3, 4, 5, 6 places. So my horizontal asymptote's there. My vertical is still running through the y-axis. And then my curves just go in the top right and bottom left. Did it say? Yeah, that's it. Okay. If it wanted domain and range here, my domain starts and stops actually. It's negative infinity to 0 and then 0 to positive infinity. Range, negative infinity to negative 6 and then negative 6 to positive infinity. Any other questions from 1, 4 or 1, 5? No, that was, sorry, 1, 3. Questions on this side from 1, 4 or 1, 5. So now you're talking all your transformations, finding the equations, and then your functions. I'm so excited for you. You're going to kick butt on this test, right? It's easier when all of the answers are right. It makes grading a lot easier. Okay. The first one is actually not terrible. I think it's because I've made you practice this so many times, but this was not terrible. Okay, the graphing part, which is good. Your domain is negative infinity to positive infinity. I haven't taught you how to graph a piecewise function, right? So you're assuming that those arrows continue on in both directions. And then your range goes bottom to top, also negative infinity to positive infinity. Then in order to find your increasing and decreasing, you have to find your max and min. So the order you do this is, it doesn't matter. I would have jumped to find my relative max and min and then go back to increasing and decreasing. When you find them, you have a minimum here and a maximum here. And then from my increasing and decreasing behavior, it's decreasing from negative infinity up to this x. You have to use the x value. Then it's increasing from that x, which would be negative 0.5, to the next x, which is 0.5. And then it changes and it's decreasing from that 0.5 to positive infinity. So that looks like this, okay? Again, most of you are pretty good on that, so good. I think I tell you to round to the nearest 10th on the test. It will tell you, just follow instructions. Your max and min, again, most of you did pretty good. Don't forget, you're going to trace each of those points. And your zeros, make sure you list them. I don't want the y-intercept, only the x values from where it crosses the x-axis. It happened 3 times this time, so all 3 had to be there. All right, even and odd. Even is symmetric if the left side equals the right side, like if it's literally mirrored each other, and that's not happening here. This does look almost like it's odd because it goes up to the left, down to the right. If I were to flip it around, it has that same pattern. But what happens around the axis has to mirror each other. So if I'm here at 0.5, 2.4, then I have to be down here at negative 0.5, negative 2.4. It's not mirrored exactly. If the plus 1 wasn't there, this actually would have been an odd function. Your backup to that is to check with your equation. So if I put the negative x's in, they don't go away. That would have been even. If I put the negative x's in, this guy's going to change sign because it's got an odd exponent. This guy is going to change sign because it has an odd exponent. This guy's going to change sign because it has an odd exponent. But this will never change signs because there's nothing to plug in there. So that 1 is what stops it from being odd, which means it's neither. And then the value, and this should be one of the easiest questions you have to answer. You're going second calc, go to value, type in that negative 1.6. It was 31.9555, whatever. That 5 would bump the 9 would bump the 1. If you were rounding this to 1 decimal place, this would have been 32. Okay, this is where it gets messy. This is your piecewise function. You have to know how to graph a piecewise function by hand. So both of those parts go on the same graph. We said there was a couple different ways to approach this. One is graph the equation of the line. So I'd start at negative 3. My slope is up 2 or over 1 or down 2 and left 1. And my graph would do something like this. Because it says less than or equal to -2, I only keep where it's less than or equal to -2. So I'm going to erase all of this, and I go all the way to where it's x is -2, less than would be left. The next part, -x² plus 1 is it's a solid, thank you. It's a solid circle because it says or equal to. The next part is your parabola. This is a parabola up 1 and upside down. So typically it looks like this, but I only want to keep where it's greater than 1. So I erase all of this. I put an open dot at 1 because I need it to be greater than, not including it. But I do need the rest of it pointing towards the right. Now, when I look at domain here, if I go from left to right, the arrow on the left points left and the arrow on the right points right, but there's a gap there. So it's going to go from -infinity to this x value, which was -2. It includes it because it's solid. And then it stops and starts again where x is 1, but doesn't include it. So it gets a parentheses and it goes to +infinity. Both arrows point down, so range starts at -infinity, but the highest y is here at 0. It's an open dot, so it gets a parentheses. It is increasing from -infinity to -2. It is decreasing from 1 to +infinity. It is not constant at all. There actually is no zeros because that is an open dot. It is not even or odd, it is neither. And f of 1 is again an open dot, so it does not exist. Your difference quotient is f of x plus h minus f of x all over h. It's squared, it's going to be squared. That's x squared plus 2xh plus h squared plus 3 times x plus h minus 5. I'm going to distribute. Then when I go to subtract it, I would line them up. It's minus 4x squared, minus 3x, and plus 5. And then put them all over h. You guys, please work tonight. I do not want bad test grades. I hate it.
Is there another way to graph the piecewise function? Like